Let's address the concept of functions. In a lot of our projects, we have custom functions that are defined that execute different pieces of logic. When we look at every Arduino program, in fact, setup and loop are two functions. Setup is only executed once, and loop is run again and again. When we take a look at how the function is defined, typically the function first is specified with a type that it is going to return. In this case, our takeReading function is going to return an integer. In the case of our loop and setup function, void denotes that the function is not going to return anything. Next, after we specify what type of variable, or if any, is being returned from our function, we have the name of the function, followed by parentheses or brackets, and within here there may be one or more arguments that are specified that our function can operate on. As an example, in this particular function, it returns a Boolean value. So isSwitched when called will return a Boolean or true-false value to whatever is calling it. So in our loop function, we can do if isSwitch engaged, and if that's true, we execute some logic here. In this particular case, our functions takes an argument. So in our convert to Celsius function, it returns a floating point value, and it also takes in a Fahrenheit reading, which is of type float. So if we were to call this particular function, as an example here in our loop, we would say convert serial.println. Let's say we're sending it to the output. We call the convert to Celsius function, and we pass in the Fahrenheit value. We can say 35.2. Alright, and once that's called, the convert to Celsius function, the value of Fahrenheit reading would be 35.2, and in here, that's where we access our 35.2 value, perform our calculation, and return our floating point number. In this last example, we see a function which takes multiple arguments. So calculate sum returns an integer, and it takes a number 1 and a number 2, which are of type integers. Here we put a comma between the different arguments to denote one argument from another. Within our function, we can access the values of those variables, num1 and num2. Here we define a local variable, sum is equal to num1 plus num2, and then we return the result, which is an integer sum, just like our function defined, back out to the calling program. So to call that, I can do serial.println, and I'm going to call calculate sum. And if I pass in 5, 3, I'm going to get 8 being returned. And that in a nutshell is functions and how they work. Let's talk about arithmetic operations. You'll see in Arduino we perform a lot of calculations based on external sensor measurements, and also if we want to interact with peripherals, sometimes calculations may be involved. The arithmetic operations, the core common ones, are addition, subtraction, multiplication, division, and modulus calculations. So to perform addition, we can do int total is equal to 5 plus 3 as an example. And if we have readings, which we define as integers, we can do an int total is equal to reading 1 plus reading 2. That's going to take the value of whatever is stored in reading 2, add it to the value of whatever is stored in reading 1, and store that new value in total. To do subtraction, as an example, int difference is equal to max reading minus min reading. So we use that minus sign to perform subtraction. To do multiplication, we use the asterisk symbol. So int scale amount is equal to reading times scale factor. This is going to return whatever the value that reading is multiplied by whatever is stored in scale factor, and it's going to assign that new value to scaled amount. To perform the division, here we have int measurement is equal to reading divided by 10, and we use the backslash as our division indicator, and that's going to divide that reading value by 10 and assign that result to the measurement variable. Another sort of handy operation that you'll see is the modulus, and modulus just means remainder. So as an example, 10 modulo 3 would be equal to 3 remainder 1. As 3 3s are 9 and there's 1 that's left over, the modulus gives us the remainder. And we use the actual modulus calculation in our stopwatch program so you can see and get a good idea of exactly how that helps us out. That's arithmetic operations in a nutshell. The last topic I would like to address is structs. And basically, a struct is a way of combining several different characteristics to form a variable. So as an example, here we are creating a struct called joystick reading, and associated with this one variable, we have 3 individual values. We have an X position of our joystick, a Y position, which are both of type integer, and a Boolean variable, which is button pressed. When we want to define our own variable, which is of type struct joystick reading, we can do it like this. We can say joystick reading, which is the type of the variable, and the name of the variable. Remember, this is no different than if we said int reading. Remember, in our classical definition, reading is the name of our variable and int is the type. In this case, we're saying current reading is the name of our variable and it is of type joystick reading, which is a type of struct. When we want to access or set the individual values of our struct variable, this is how we do it. So we can say current reading dot X position is equal to 125, current reading dot Y position is equal to 225, and similarly we can say current reading dot is button pressed is equal to false. The benefit of this is that we can group associated values for a variable and have everything housed in one complete variable, sort of like we're creating an object in object-oriented programming. And that, in a nutshell, is what a struct is. We'll see a struct being used in our infrared repeater circuit program, where we combine a lot of information about an infrared signal and store that in a struct object. This was just a quick introduction into some helpful programming concepts, but there's quite a lot to learn about programming. The course isn't meant to make you an expert programmer. It's meant to introduce you to the world of Arduino and programming concepts. So to help you out, if you want to improve upon your programming skills, I'll post a few programming resources and books in the resources section for the lecture, and you can take a look at this in more detail to delve a little deeper into programming concepts.